So make sure that when you go to your site that you go to two-step equations first. Here you will see the problem. You have the left side of the equal sign here, the right side of the equal sign, and down below you have some directions to help you. It says model the equation by dragging number and x tiles to the scale. You'll remember the x stands for your variable, and then you have your positive integers and your negative integers. So there are 6 step-by-step problems to solve. So first we can look at our equation. We have 3x plus 2 equals 14. So on the left side of the equal sign we should have 3x plus 2 modeled. So first, 3x should mean that we have 3 integers, positive and x. Oh, that doesn't look right. I wonder what I did wrong. This says that this is x plus 3. So I don't want x plus 3, I want 3x. How can I get 3 x's? Maybe if I take away the positive integers and show the x as 3, that will work. And you can see below that it did. So we have 3x, and now we need to have plus 2 or positive 2. So I'm going to go ahead and add 1 and 2. So as you can see down here it shows the same thing as the left side of the equal sign, so we can go over to the right side of the equal sign, which is a positive 14. So yes, we have to drag 14 positive integers. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. And again, our balance should be balanced. This 3x plus 2 is equal to 14. Now we're going to check it so we can move on to the second step. It says your model is correct. Now let's solve the problem. You need to isolate the x tiles, and if you remember, if your x tile is connected to another integer, that means it's a coefficient. So we are not going to move the coefficient first. We're going to do that second. So it says here there are 2 positive 1 tiles on the left. To remove the positive 1 tiles, place a negative 1 tile on top of each one. This means that we're doing the inverse operation. So we'll go ahead and take a negative 1 over here. That gets rid of that one, and a negative 1 over here. That gets rid of that one. And remember, whatever you do to the left side, you have to do the right side. So we did a negative 2 to the left, so we're going to go ahead and do a negative 2 to the right. And as you can see, now it's still equal. Our second step is to get rid of that coefficient, which is 3x. The directions say down here, in order to get the 3x, you have to pair them up. So let's see if that is this, or if they're going to give us another step. Oh. Now we can take our 3x tiles together and have a value of 12. You need to find the value of one x tile. This is a division problem. Check the divide button. Click the divide button to arrange the tiles into 3 equal groups of 4. So because this is a computer program, they're going to go ahead and do a couple things for you, but they are reminding you that in order to split the coefficient or separate the coefficient or divide the coefficient, you have to then divide. So they put it into 3 nice rows. So we should be able to go ahead and, oh, that wasn't it. Let's see. Let's see what this button divide will do. Oh, so they're dividing row by row. Oh, what happened to our problem? Well, you could see that they were dividing row by row. And so how many rows were we going to have if 3x equals 12? We were going to have 4 rows. The answer should have been 4. So let's see if this second one could be a little bit better now that we played with the buttons. Alright, our next problem is 3x plus 3 equals negative 6. Like before, we want to make the left side of the equal sign the same as our problem up here, and the right side the same as what we have here. So let's start with 3x, which means we need to put 3x tiles. And then we have positive 3, so it means we need to put 3 positive integers. And we should be done with the left side. Right side is negative 6, so that means we need to put 6 negative integer tiles. And you can see, oh, I put 1 too many, and the balance is not balanced. That would be just right. So let's check it. And let's get to solving. Remember, in order to move your non-coefficient, which would be the positive 3, over to the right side, you have to do the inverse operation. So these 3 are positive. To do the inverse, we need to do negative. So we're going to do negative 1 over here, and we're going to do negative 1 over here. Because whatever we do to this side, we do this side to make it balance. Do a negative 1 over here. Oop. And then we do a negative 1 over here. Oh, look, it's still balanced. Negative 1 over on the left side, and finally a negative 1 to the right side. Now remember, we had negative 3 on the left side, and we added a negative 3 on the right side, and we got a negative 9. So now we are still balanced, and our problem is 3x equals a negative 9. So we're going to check it to see if that's right. And now let's see if we can get the dividing correct this time. So there's 3 x's over here, and there's 9 integers over here. Let's see if they can divide it to put it into rows. And the tiles on the right side of the scale have been arranged. Each group is equal to 1 tile. The value of x, therefore, is negative 3. Click the next button to continue. So this is the final stage. You just simply have to see that there are 1 row, 2 row, and 3 rows. And because we have a positive over here and we have a negative over here, that means that the answer will be a negative 3. You can see at the top right, they have all the steps shown for you as well. So good luck guys. Remember, there are 6 problems to try on this, and I hope you have fun. Make sure to email me if you have any questions.